in my experience of what I have witnessed in the last 2 decades, I would try to touch upon that part as we conclude today's discussion. I would rather start with a very connected story to me, right? I kind of started my journey as a mathematician. I studied mathematics pure in my graduation, and then started to see that there was no use of mathematics around me. It was very discouraging, and I'm talking about late 2000, early 2001 and 2002. So I'm from Delhi, DMRC was kind of coming up, and I always kept thinking, is there any way that mathematics that I've learned can help make Delhi a better city? It was a constant question in my mind, because I had seen Delhi from my childhood, and things were getting bad and bad as the days were progressing. So that was the kind of inclination I had. So I'll talk about the journey that really fascinated me, and I'm not going to bore you with that. I have made use of AI to give you that journey. We'll continue. Just hope the video runs. The video is a glimpse of how it all started, where I see from. Of course, disclaimer, if anything goes wrong, it's the fault of AI. I'll talk about that in the second half. But as of now, to my better understanding, how things have evolved in what we today call something as artificial intelligence, it has a lot of components within it. And it's not something that has come out of blue, right? It was always there. If somebody asks me, AI was there in late 50s, mid 50s, yes. Supercomputers were already using it. The only phenomena that has changed it, it has become accessible to us now, to far larger extent that we could imagine. We have it in our hands. That's the biggest change that has happened. And this journey, I try to fill it up today. And let's see if we are able to do some good connect between them. So I think my introduction has already been done, so let's quickly jump onto this video. Can we reduce the lights a bit? I think it will become much more visible. It's a bit long, so the entire evolution that I was supposed to talk, I put in there, and rather I'll talk something very different from there. It's okay, we'll get started then meanwhile. And I'll join you guys in. First of all, thank you so much for that patient visual effect to be given. Mind you, this was my initial presentation. I converted it into a video because I was constantly asking this question, what is it that AI can do, AI cannot do, and I can contribute here? This entire presentation, if you look at the bookmark, is prepared by Pictory.ai. I gave the content. They created the video. That was my job. Human-centric AI. I could have given the entire 40-minute session on just these slides that you just saw. About 80, 85 of them are there. My 45 minutes could have gone. I saw one missing link, and that's what I'm going to talk about today. I'll take a minute to question in the group, how many of these things that you saw came out unfamiliar to you? Completely unfamiliar. People who say that less than 30% of what I saw, I had seen before. Okay, most of it you would have been aware of it, right? Because this has been the journey, our generation, a generation prior, and the younger ones has also observed it. What has gone in between these eras are the three stories that I'm going to talk about. As per my understanding, these three golden nuggets have actually led to where we are today. And I'm going to talk about not just the technology part of it, but the people part of it, who made actually the biggest difference that I have witnessed. And I have read through some of the literature which these guys have printed and kept lying for years before it turned into something that we see today. And I'm going to talk about those three stories here. I think if you are sitting in the room, you are pretty much familiar with some of the common terms that are used in data science, one of them being some algorithms, which are very common, something called as a decision tree. How many of us know who made it possible? When was it made possible? And what typically goes behind decision trees? Mind you, most of the algorithms that we are using today, they are based on decision trees. Absolutely based on decision trees, nothing beyond that. And they are the advanced versions of decision trees. And they are very simple if-then rules, nothing beyond that. They're very, very simple rules that we can apply as if-then. And that's what the extension happened, and I'm going to talk about what actually led to the biggest turnaround in the century when the birth of decision trees actually took up. So you can imagine that there was a time when we all have been doing manual calculations, right? And when we say manual calculations, we are talking about all decision making happening by either writing on papers. These are my possibilities, these are my criterias, and I'm going to evaluate based on my best understanding. Nobody thought that this entire thought process that is working in our brain is actually working like a tree, is actually operating on the principle of if-then. That was the first thought when the mathematics for decision tree was created. Who did it? Actually, let's try looking at it. The challenge with, let's say, subjective decision making, there are a few of them. One of them is, of course, predominantly one we cannot erase the errors. Once taken a decision, we will have to go through the consequences. So why so much importance given to computing bases like decision tree? Because at the very outset, they were giving us all alternatives. And it was not that we were dealing with some non-exhaustive list. It was trying to provide us as many options as are possible. Some of the errors which in personal judgment predominantly exist is biases, the subjectivity with which we take those decisions. And of course, the efficient system is lacking there. So the gentleman, I hope the name is visible, Ross Kunlins, he's the man, of course, from a statistics background, having a basic understanding of computers, was the first gentleman to be able to introduce and call it in a structured way, called as decision trees. And what did he do? That's an interesting part. We all have heard about, or maybe have applied it in some of our problem areas as well, as the idea of dividing or creating a structure which is well defined, right, based on the attributes of the situation that we are trying to solve. So what decision tree is more importantly able to do is group the data based on those attributes. Now, what are these attributes and where are these attributes coming from and how do you analyze them was something the entire structure of decision tree talks about all the time. So what you give as an input is a way to group, is a way to cluster the overall data. And the first thing that led to the entire journey of what we today are calling as ML, which is machine learning. The simplest of those machine learning models, which start with the decision tree, has what is called as the ID3. Anyone aware of ID3? Heard of ID3? So fundamentally, ID3, or making it simple, today if a machine hears a male voice or a female voice, it is able to classify it as male and female. How? What are the attributes that the machine is considering to classify the voice? Any? One of the features is pitch, the frequency or the rate of speech that we speak at, the bass in our voice, right? Even the volume alterations that we follow. What are these? These are attributes, right? But what is happening behind the scene with the attributes? They are getting classified. In simple words, they are iteratively getting dichotomized. That's the name. That's the name that came from. Very simple. If you read the paper which is presenting ID3, it is so simple that you go back to your 10+2 level of mathematics. That's just beautifully written. And all the three stories have this commonality. I'll talk about that. So this revolution, nobody talks about. Why nobody talks about? Because this is dull. We want to hear how ID3 can go inside my phone and do fancy things for me in Instagram. But we don't want to talk about ID3. Trust me, it's not possible without ID3. A basic classification model has to be built. Similarly, any of the prediction models that we build, a basic structure has to be defined. That basic as the ID3. So if you do get a chance today, write it on ChatGPT-3, which makes use of ID3. Please find out what ID3 does. Mathematically, it's very simple. But in simple words, this was a breakthrough according to me. Trust me, it is not highlighted anywhere in the literature. I feel this made a big difference. If decision trees were not there, classification wouldn't have been that simple as we do today. I don't see that happening, ever. What it does, in simple words, even if you today it's very advanced, but initially the challenge was that we had to give certain criteria to bifurcate, to do the dichotomy part, to do the partition of the data so that it can identify. Today we are so advanced that you throw the data, it itself will partition it for you. Or it'll give you 3 alternative how to partition also. That is also there, which is even more advanced. The quality of it depends upon how people are reading it. What is relevant where? That's where the human-centric AI part comes in. That's why I'm emphasizing on all these 3 stories, one of the common part is ID3 or decision tree. It was not that the gentleman developed on his own. The decision tree literature was already there. What he was able to do is use it for ID3 creation. That's where the difference comes in. And in the third story, I'll connect back to this thought that people who generally are working on the fundamental research part of it and the people who come up with extraordinary reach to the society, In my experience, seldom you would find them common. They are generally two different class of people, and this is where I'm emphasizing on the people part for this. So what did this give us? It gave us that wherever we were making some qualitative judgments, we had a choice. It was given an alternative. What are these alternatives? These are alternatives which we are assuming they have no influence. We are assuming or we are ignoring. So either we have the alternatives that we are unknown of, we are unaware of, or we are thinking they are non-significant. This approach takes that bias away from the study. I'll give you one small example to connect the dot. Very recently at TVS Motor, we were working on paint efficiency. I'm sure all of us are really connected with the thought that wherever there are automobile manufacturing happening, paint processes are happening, there's a huge loss. And I'm talking loss of the tune of at least ₹1 million every day. It's as simple as this. I'm giving you the number, actual number that is happening. And we were talking about how we can control it, reduce it. There's an entire process to the paint loss journey. Cutting the story short, I was brought into the team a year back. I went through the entire process for 3 months, try and understand. Of course, I can't understand the entire process. These guys have been there for 20 years. I tried and put milestones at each step in the process. What I was able to come up with was a little different than the approach the team was taking. Some of the parameters which they took it by default, something which is very common if anyone is from the background, design of the jig on which you load the part which gets painted, was completely ignored in order to do the paint yield calculations. They thought it's a given. We can't change a design. It's on an assembly line. How would you change a design? Mind you, they had 25 designs already available. They did not know which is the optimal one because they never thought it. What I'm saying is, when you start to apply approaches like decision tree, the whole keyword of thinking out of the box doesn't remain out of the box. It's already there. It's just that we are deliberately making an attempt to ignore it, or we assume it's not going to influence. Entire story, that jig design came out with a significance of 0.12. I'm not sure how much that relates to, but 12% of influence on the paint loss by one parameter meant huge for the business. Huge. And I'm talking to the tunes of 10 CR saved annually, just because of an identification of a variable. I'm standing here today because of that. Trust me. They would have thrown me out of 4 years because there was not happening big things, right? Oh, big things are not going to happen on its own. You have to be there in the business, right? That was big. Anand met me during that time and it was from there, right? What I'm saying is, and I did not use anything fancy there. I used an approach of identifying all alternatives and then measuring them. Because identification is just one part of the process. So the choice comes in. I'm highlighting that part of the whole story. The choice comes in. You have alternatives to look upon. You don't know whether they're going to have an influence or not. Mind you, if I show you the mathematics, you will laugh. It's so trivial. It is simple as y equal to a plus x1, bx1 plus cx2. Simple. My management did not accept it initially. They thought it's too trivial. Too trivial. Trust, seriously. We all want it. We all think that way. These pieces are a little different. And all the 3 stories that I have picked up, please take this commonality today from the session. So, look at what he applied this decision tree on. And I'm very particular about what I put on the slides and what I speak. So you can always go back and check, right? I've used AI everywhere. Yeah, but not without validation. I'm a very critique in terms of that, right? So you can see, right? Today we are working on a project which is based on sustainability, comparing rainfall, TDS, depth inside water to help improve, identify locations for production. Can you connect the dots? Why? Because we are aware in 20 years the water levels is going to be so bad that forget about paint, you can't manufacture even one single automobile. Where will the water come from? I mean, the gallons of water that is used in any manufacturing, can you imagine? So that's the level where these simple mathematical components can play a huge role. It's about choice. And you pick the choice and apply it in areas that have greater impact. We'll talk about the impact part. So what is the evolution that I'm talking about? The ID3. And the evolution started with the base ID3. It had its limitations as well. What were the limitations? Of course, missing data it could not ignore because it needed the data to classify. So big challenge. Noises, right? Very unique example. Increase in the number of trees in Delhi NCR during the years 2006 till 2010, right? Highly correlated with increase in the number of buffaloes born in Bihar. What does that mean? High correlation. How would you know? How would system know? He is only given the task to find out correlation. This is actual study. They were trying to understand what is influencing number of trees growth, right? They put in all variables. Non-exhaustive, so high, they made it even bigger. What I'm trying to say is, even the sophisticated of the systems will not be able to identify noises. It is the job of people. Very important, very difficult. With the amount of data and the complexity that we are dealing with, it's even tougher. So it plays a key role. So ID3, of course, in 70s, it was difficult to identify those noises directly. And as we all understand, most of these algorithms, most of these models are not fit for the real world applications. This is what our management continuously reinforces. That they are good to be presented in a conference, they are good to be discussed in a conference room, but they're not that great to help me take a bottom line decision that directly impact my strategy and influences my bottom line, is the real part. So the same challenge was there for ID3 also. So in 80s, he developed C 4.5. In most of the software, you will find by the name of C, if you have exposed yourself to any statistical softwares. So I'm talking about MATLAB, SPSS, IBM SPSS, if you recall. They have it by the name of C3, C4, C4.5, which is nothing but an advanced version of the IDs, which till date is absolutely amazing to do a job of as real-world applications like customer segmentation, fraud detection. They can actually do a very good job. And by very good, I mean 60 to 70% actual performance that you're looking at, which in my understanding is outstanding. 60, 70% if it can do for us, people can augment it. People can improve it from there. And it will be a huge difference to the bottom line. That's what I'm saying here. So the key came in the 80s. So what real-world applications are we talking about? We are talking about some of the most impactful technologies that Decision Tree has been able to do is fraud detection. How many of you are aware that most of the banks have something called the CIBIL model, credit scoring model? Anyone from a banking background here? Yeah, credit scoring models are rarely available. These are all regression-based models, mind you. But who knows the regression they are working is decision tree regression. Again, real-world application, very impactful. These models fail, but when they do really good. All models are, you heard of this? All models are useless. Some are useful, some. And they're useful to an extent that they can make an impact. And the impact is pretty big. It all depends on how you can maneuver around it. So the first and the most important one came in the financial sector. The second is healthcare. we have the gadgets today, right, in our hands. Please think about it once. How are they working? You will find that the data that they are collecting at a regular interval and the recommendations they are making, they are very well connected to certain attributes at the back end. The attributes are how they are connected to each other. Who connected it? Again, please, next time when you get an alarm which says you haven't walked for these many hours, start to think. How is he connecting, right? Where is the data flowing and what is the interpretation that the machine is making? So today, Mr. Iyer was talking about data or machines creating on its own, right? It is happening today. Trust me, data is creating, machine is creating things for us. I showed you the video. What else do we need as an example? The entire video, guys, please. Okay, let me give you a little bit more. I only gave the text. All the background that you see, the sound that you see, the pace at which it's going to move, everything. So who's creating it if we not? How many of us are aware that AI, GPTs, started with poems in 2019? Writing poems. Writing essays in 2019. 19, I'm talking, when ChatGPT was not out. This was OpenAI doing it. How? Basic structure behind every knowledge has to be based on decision trees somewhere because the classification has to happen. Until the classification happens, no prediction can take place. It's not possible. How would you know? In the data world that we are living in, how do we know prediction until we are able to classify into some buckets? Only then the next step comes in. So healthcare is yet another industry. The most loved one. I think we have heard of random forests. Machine learning people who have been using it, they know how much they love random forest. If boss says nothing is working, see, 99% accuracy. So just the joke in the world. Again, a very sophisticated decision tree. Why we are calling it forest? Because you can go by the name, right? It's a forest because it has numerous trees in it. That's by the name. Nothing is happening without some intelligent guy putting in the brain. That's the forest that we are talking about here. And what it does, classification of as deep level as you can imagine. It can cut your data in as many ways as possible to the extent that is possible. Suffers from limitations. I'm not here to talk about them today. It's not the forum. It has its own set of limitations. That's why advanced models have come. But if you ask me, it still holds ground on a lot of situations. We are working on a model where we are looking at from paint loss to transfer efficiency, right? So that's the next level of efficiency that we want to control. How much actually gets deposited in comparison to the composition of the paint that we start with. So we as a company, we decide what composition we want from our supplier. We can dictate terms to them. If we know how efficient the final outcome would be, right? But we don't know this. That's why we are now working here. And we are using random forest. It's coming closer. It's still work in process. So what's the takeaway? Very simple understanding. You don't have to build complex things initially. Build very small and kind of succeed in that. Am I running late on time? Okay. Now, I'll quickly jump onto the second story because I think it's going to take a while for this. But here, the only thing that I want to emphasize on the first story is start with simple. Start with what is in front of you. Whichever model is available, just apply that. See what can be done. Anyone heard of where is this coming from? Who are the people responsible? We all have heard of neural networks, right? I don't think there is anyone who has not heard of neural net. Where is it coming from? Go ahead. Neural, okay. So you're citing what the people think, correct. People responsible for making it possible? Okay, when was this termed neural network? Sorry? 80s, very right. Anyone? 80s is when it became available for application. When was it termed? First neural network paper is 56, right? So before going on the slides, I'll tell you this story because this is very dear to me, and I'm a little biased towards it. How many of heard of name called Andrew Ng on LinkedIn? Heard of? He's also the founder of Coursera. Coursera we know, right? He's one of the founders on Coursera. He did his PhD in artificial intelligence under Geoffrey Hinton. The guy named Geoffrey Hinton. And who is this guy? He's a psychologist by graduation, clinical. He studied, I think, experimental psychology or something, and did his PhD in the late 70s in artificial intelligence. So Andrew Ng is Andrew Ng because of Geoffrey Hinton and because of his contribution to the field of neural network. 7-page article in the journal called Nature. It's one of the topmost journals in human history that you can imagine. This is a paper which holds theory of relativity, just to give you a sense, right? 7-page paper. You know what's the mathematics behind it? How many of us are from 10 plus 2 mathematics background? Plus 2 mein mathematics tha. You will relate to this. The 7-page mathematics is about differentiation chain rule. Heard of? Birth of neural network application. 1986 paper. It's here, written on my face, as is, because I'm in so much of awe, these 7 pages. How can a man who comes from a background of psychology, has very little mathematical understanding, everything it's happening behind the scene, he's able to map our human brain in how we take one dot of our learning or knowledge and connect to the other dot. How does a child learn? There's a very beautiful video on TED, Birth of a Word, by some Mr. Roy. He was in Yahoo back then. So he recorded his newly born child's video for 6 months, complete recording of his house, 6 months, to find out how children learn to speak. So the first word uttered by the child was water. So he mapped it using wave transformation, how the child reached from wah, woo, woo sound till water. Beautiful, please watch it. Good 20 minutes video, excellent. Why I'm connecting it here is, this was the birth where neurons, thank you so much, they started to see the neurons speak to each other using the language of chain rule. They pass on information like chain rule. The information depletes the more we pass. Same concept of chain rule if you relate to differentiation. Same concept. So Geoffrey Hinton, name, how many of you are aware that he was working for Google? Please read about him. You'll find it fascinating. He was thrown out because he was not able to come up with ChatGPT before OpenAI. Somebody has to take the blame, right? He's to me, he's a Nobel Prize laureate kind of a guy, right? You please read about him. You'll find, again, the part that I was connecting to the first story. Very simple mathematics. Somebody else developed it. He used it in a completely different context. And what happened after 86? Big break of 20 years until Andrew Ng came in. Or until 2012, a competition on ImageNet came in, the largest of the image data, which Geoffrey Hinton, using what he proposed in 86, applied to classify, using the knowledge of back-forward propagation, you read about it, to classify images into accurate objects with an 85% accuracy. Am I running late on time? Sorry. No. 5 minutes. Yeah, that'll be enough. So again, a fabulous, fabulous application of what he proposed in 86, applied it in 2012. Ever since then, there has been no looking back. Whatever we have seen in the field of what we are calling it today at deep learning, branch of machine learning going into neural nets, right, is because of this one gentleman who contributed immensely, and alongside 2 more people. I'll highlight them. So I'll rush through the deck because I think a lot of story part I have narrated, but I'm okay to take up any questions on any aspect if you have. So in the 80s, of course, data was growing. This was also, so the right timing was there for this gentleman to apply differentiation also, right? So it's not just the deeper understanding of someone's capability to be able to apply it, it's the ecosystem that supports it as well. So there's a lot that goes behind. So today my talk focuses upon people part of it. But what I'm saying is the entire ecosystem was also developing. So the data was getting available, machines were getting faster. They were not considered great because nobody knew how to use them. In my Department of Operations Research in Delhi University, we had 19 theses lying on neural nets. Nobody knew how to use it, right? I'm talking about from 1988 till about 2001. You could not do much about it. The problem was neural nets were only able to understand basic information, basic data points. Complexity was missing, so it was all dark. It is dark till date also. To a large extent, it is still dark, but in a very different way. So then came a man that story that I've talked about, Geoffrey Hinton. Please read about the gentleman. You will be in awe of what he was able to achieve, what he has been able to achieve, what he continues to achieve. And the breakthrough happened. This is what made all the difference. I know it's a bit of a light. So you can imagine that no colors are there. So there are 2, 3 colors that you see, right? Red, black. If you can see another color, good for me. So imagine there are no colors initially on the dots, and the dots start to ignite as the light starts to fall on them from input to the output. So the initial color is all red. It gets classified into red, black as it moves into the process. This is what a neural network or our brain does. You show an apple to a child, how does he identify it's an apple? He starts with looking at the color. He starts with looking at the size. He starts with looking at the shape. What are these? Attributes, going back to the classification problem, right? But we can only identify with these 3? No. You can compare an apple to an orange. Then what's the difference? Then there's a lot more features to address. How a machine identifies face is the same. It's the same problem. It takes the entire snapshot and creates dots on your face, as small as you can imagine, and then works on top of it. So this was the phenomena, backpropagation, which was proposed in 1986 by Geoffrey Hinton, which is based on the simple mathematics that I talked about. So as I mentioned, it was not new. Hinton used it. In 70s, it was already neural network was available. People were using backpropagation, forward propagation also, not in the way he used it. That's the only difference. That's why 80s become predominant or very famous in terms of neural network and its application. So in 86, as I mentioned, so I was right, in groundbreaking paper that changed the game. Please read about it. Very simple language. How it is doing is, of course, it's a journey that we all have to cross. But I'm trying to give us a sense of the contribution of people in the entire journey. How people were able to pick things completely uncorrelated. And I'll conclude my talk on that. And were able to produce some significant changes. So from research to applications, as I mentioned, it remained dominant. And then ImageNet Challenge came in 2012, as I've been mentioning about it. where they were able to achieve some stunning 85% of the image classification, and there is no looking back after that, guys. There's no looking back. Ever since then, it is to the next level that we can imagine. So these are the two more gentlemen who were alongside Hinton, worked tremendously on building what we today call a CNN, convolution neural network. So the gentleman Khan that you see here continued to work on the CNN, which is how images can be classified more with more features and optimized way. And so what we see today, facial recognition kind of major work is done by Lichun. And Bengio kind of started to work and continued to work on the NLP part of it. And I have a story which we can of course connect, how Google Translate moved from 27% to 73% overnight in terms of its accuracy for translation. And a Japanese wrote an article for good 3 pages. New York Times has an 80-page long article in March of 2014. Please find that out, read it. I dropped my class, I used to teach at IMT Ghaziabad at that time. I dropped my class to read that article, it is so fascinating. So that's the article that changed everything, and they used what was the work of Bengio at that time. So what industries, of course, I think we can skip this part. I'll take 2 more minutes to wrap up the last. So these are quick ones. Of course, we have been able to, I always think that we are extending human capabilities to machine, from vision to voice to touch. I think the smell is the next. And if we're able to achieve that, I think we will be very close to saying that as much we can create, maybe not, but to a closer extent we can. But of course, it's not happening in the next good 4 or 5 years, up till what I see. I mean, if it happens, nothing like it. So this is what deep learning is. Whatever we see after what neural network has happened, so it is no more a class of machine learning alone, it is a subset of machine learning, which is called the deep learning. And by the name, it clearly means the deep part of the learning, how it happens in the brain. And the third story is about generative AI. And it is an extension of what happened in the second story. Again, if you go back, look at how Gen AI has come to an extent of where we are. What do you think is different that has not happened in the previous two? So decision trees were one, led to machine learning. Neural network was the second that led to deep learning. What led to Gen AI? Think. You see the journey, right? The connect between the two. So I love to call it like a sense of creativity. We have seen this, right? We are very familiar with the rise of GPT. What are these? What does this T stands for in the GPT? The transformers. What's happening there? Who is the one who made it possible? So that's why Google threw out Geoffrey Hinton. He was still responsible for coming up with models like transformers till 2017, but they were still not able to come up with ChatGPT. So that's the strangest part. So transformers were built by Google. So the initial model is again presented in a paper called Attention is All You Need. It's by the title, Attention is All You Need. What's happening in the transformer? Quickly look at it. Oh yeah, so this is the one. So the story begins in 17 when the Google brain introduced the transformer architecture. Now what is it doing? How many of us seen a video wherein you still hear the same sound? Anyways, I'll bring it back to rather here. A child, again, the learning goes back to how we learn as human beings. You give them a word, they won't connect. You give them a sentence, they will start to think, they were referring about this. Same, this must be with everyone, I think. When you hear someone talking in different language or watching a movie in a different language, if you don't have the subtitles, how are you able to understand what they're speaking? Most of the time we get the context, isn't it? Even without, I think, in my childhood, I remember I never used to understand the English movies at all. But I used to watch them because I used to understand what's happening, right? Especially the Bruce Lee movies. All of us would have gone through, right? How are we understanding it? The same concept. We are not picking up word by word. We are picking sentence by sentence. That's why transformer. So neural picked up features, right? So breaking it. Here features were aligned in NLP to create a sense. So if you read a story which says Stephen went to Harvard to do his master's, and in the 4th chapter it is mentioned he also studied this. How are you connecting he to Stephen? How do you connect? That's why the title of the paper, attention is all you need. You only need attention. The more you read, same thing happens with us, right? If we are reading it attentively, we are able to connect all the dots in any article that we read. Why? Because our brain is then connecting all our learnings. So let's say today if you would have heard me 20%, you will take everything that you have spoken. If you have heard me just 20%, this is attention is all you need. Transformer architecture in process in our brain. Exactly, that's it. Nothing beyond that. So this is the third story. Again, the people who have made it good was Geoffrey Hinton, of course, and his team. It's a 50 author article in the history of literature. Never has happened. 50 author article. Find on Google, you'll find. Attention is all you need, you'll find. So they'll have a smaller version, but then you can read through. So they talk about this. But who came up with ChatGPT is what we know, that OpenAI. And please read about them. Of course, I wanted to talk about how they were able to do it, but you can. So this is what I was referring to. In 2020, I was wrong, 2019, 20, they were able to write poetry, generate the prompts, write essays. They were able to do fabulous things. And this has happened because of the agility, mind you, nothing else. That's why connect to the conference. OpenAI, what they did differently than the Google team, the Microsoft, they were all working on it. Copilot was way ahead. How were they able to make it is the agility that they saw. This last minute I'm wrapping up. Yeah, thank you. So that's where it happened, and the final revolution that we see today in ChatGPT is the Delhi model, which is moving from text to images. So it can understand images also. You throw an image to ChatGPT, it is giving you inferences. So that's what, yeah, so I think the impact would go long, but that's what quickly I wanted to share it across. There are a few things which I can talk after we meet, which is about some work that I have had the opportunity to work for. During COVID pandemic, I was working with a company called Protibity. We were approached by Times Now Group. They were in collaboration working with the Ministry of Healthcare, and they wanted to come up with a model to forecast the extent of the pandemic. I'm talking about 23rd March of 2020. We came up with the first model on 1st of April 2020. In between those 7 days, I, along with the 2 team members, we produced 3 models. One was a time series statistical model. Another was a machine learning XGBoost, as we just spoke about. And the third was SEER modeling, which is very specific for pandemic like these, or is very common in epidemiology studies. Why I emphasize here again was there is an uncanny match. On 1st of April 2020, we projected there will be more than 1.8 CR cases, and my CEO asked me to resign. He said, we can't print this. I said, I'm not saying this. Data is telling me, and the model is saying. Whether you accept it or not accept it is your job. They gave this to Times Now, they gave it to the ministry. We printed 16 reports after that. Every second week we were printing a report of these models. One of the groundbreaking work that I personally think the team did was to be able to come up with some very good model at the right time. So algorithms are great, but you have to have the uncanny knack to pick the right models. Very important. We are living in the world. I don't think we have the patience, the nature to be able to build algorithms, but we can quickly build up models. So that's what we can use models which are existing. That's what I want to end my conversation on. Happy to take up any questions in case we have to do any right now, or we'll do it in the break. But thank you.